Hello, everyone. Thank you for joining us today. My name's Taylor Cox. I'm a senior applications engineer.
Hi, everybody. I'm Mark Bay. I'm one of the market segment managers here at Makino. Taylor, thanks for joining me here today. We are up at Makino Center of Excellence in Auburn Hills, Michigan. And Taylor, today we'll be talking a little bit about the process of making decisions on how to do a mold insert.
Yeah.
Like we have a print here. And if you don't mind, like taking a look at it and take us through a little bit through the decision process that guides you to, which machine to use, which technology to use.
Yeah,
and so forth.
Absolutely. So first thing that I do when I look at any of these prints is I look at tolerance. So some of these are pretty open, but our tightest tolerance on here is plus or minus a tenth.
That's pretty tight. So if you think about a machine platform that you would recommend, would you shift this more towards the higher precision machines?
Yes, I would, especially for production part. So I would recommend a J series machine.
Okay. And when you say on a production part, so if it's a lower run or just single piece or so where you need that, we could do that on our other equipment as well, right?
Yeah, absolutely. The difference is, this machine is designed to cut to that level of tolerance all day, every day, right?
So today, in 6 months, in 2 years.
Correct.
It's going to be consistently giving you these results.
Yeah, this high level, absolutely.
And I know we're not talking specifically about the machine, but maybe you can tell us a little bit about what the differentiators are on the J series here that make it more suitable for these high precision type of jobs.
Yeah, absolutely. So the big difference when we're looking at a J series machine, basically just higher accuracy components that go into the machine itself. So ball screws, linear guides, thermal stability, larger chiller. Those are the key factors in holding those tolerances over a long period of time.
Okay, great. Cool. So we'll do this on a J-type machine.
Yep.
And what else are you looking at when you look at the print?
Yep. So first thing was tolerance. Next thing I look at is surface finish. So 12 micro-inch RA surface finish. So that's a pretty decent finish. That's going to be a 5-pass machining on this.
Now 5-pass means 1 rough and for trim cuts?
Yes.
Okay.
So at Makino, we include the rough cut. Some other people, they say 5-pass, that means 1 rough, 5 skims. When we say 5-pass, that means rough, 4 skims. So total number of passes. So that's where we'd start. I always look at the material next. And in this case, this material's S7 tool steel.
Is there something specific or special about S7?
Yeah, so S7 will actually move, right? So, which is good for the functionality of this part. It's not going to shatter. It's not going to break very easily. However, when we're machining this, any internal stresses, this material is going to move it on us. So what I would recommend in doing this part would be called +1 machining.
Can you elaborate on that?
Yeah, absolutely. So +1 machining is because we know that this material is likely going to move slightly during machining, especially after the rough cut. What we're going to do is we're going to do rough cut, and we're going to run our second cut twice. So rough cut, second cut, third, fourth, and fifth. So I say 5-pass machining, but because we're doing what we call +1, it'll end up being 6 total.
Okay.
And that's strictly just because I anticipate this material is going to move.
So if all things equal, but you have a different type of material here, like, a D2 or something like that.
Yeah, if this was D2, I wouldn't start off doing a +1 machining. Yeah. D2 is a lot more stable. So yeah, that's just why I look at the material. So if I can anticipate if there's going to be any issues, movement or anything else. Yep.
So we have really 3 aspects to look at here, right? It's the surface finish, it's the tolerance requirements, and then the material.
Absolutely. Those are the three key things that I look at on every job that I'm about to do.
Okay.
What we'll do is I can show you on the control what we're going to do, show some of the technology, and then kind of graph out a program, show you what we would be doing for kind of how to process this.
That'd be great.
Okay.
Thanks,
Wonderful.
Taylor.
Okay, so now we're going to go through selecting technology on the machine, Mark, and we're going to be loading a program just to show you what I'd be doing on the machine here. So we're on our J machine. We're going to select Active eTech. Then we're going to go through and select all the different stuff. So we hit our clear button and we choose from our list of available wire diameters. So in this case, we're going to be running 10 thousandths brass wire. I didn't mention it earlier, but this part isn't too thick, too thin, and we don't have any really small radii or anything. So we're going to use 10 thousandths brass wire to process this. That's the standard in North America, 10 thousandths brass wire. So we're going to use 10 thousandths brass wire, and then we've got a list of all of our different materials. So this is still a steel material, right? So we're still going to use this tech. And then workpiece thickness. So this workpiece thickness is 2.4 inches, so 2.4 inches. And then technology-wise, so we've got a bunch of different technology in here, but on this one, we're going to be with our nozzles away. This isn't going to be flat top and bottom. We're going to be doing two orientations. So we're going to be using what we call both away technology. And then we talked about hitting that surface finish. That's going to be a 5-pass surface finish. So we'll hit finish 15, select, and then we'll hit search. So these are the 5 passes that I was talking about. So there's our 5 passes. And then I had talked about doing a +1 machining. We can see that +1 machining is available for this technology and this thickness. I click that, and you can see that it adds in the second pass twice. So 1117 and 1117, right? So just more error correction before we get down to the final finish. So same thing that you would do on a CAM system, right? We provide all of our technology databases to the CAM companies so that it would basically be the same process. You would select the same things on the CAM side. So I've already got this programmed, hard-coded in a program. So now I'm going to show you loading that into the machine here. Get my USB drive out. Okay, so I got my USB drive in here. We'll go to our program screen, file manage page. And then we're going to click on our USB. And I've got 2 separate programs because I would typically do this in two operations. So I have 2 separate programs. So we'll load the first one, load the second one. So program 1 and 2 in here. So again, we can see all of those offsets and all of those E numbers are already in the program because that was selected when the program was created, okay? So if we come up, we load our program 1 into our memory, we scale this job out, right? We can see this is the first orientation, and then we'd run program 2, and then we can see the second orientation. So depending on if the material moves a lot or not, you may have to alternate in between each pass. So rough cut, second cut. We only save that for extreme situations where your material's moving a lot, because now I have to keep flipping back and forth in between each processing. So
would you expect that in this particular job or no?
In this job, I don't think so. I think the +1's going to get rid of that. And I don't always start inherently adding a lot more time. So this one should be fine with you just using a +1 to start off with. So there we've got it, one orientation and then the second one. And then what you can do is you can load up multiple pallets or something, right? So however you want to fixture the part, you could do it that way. So that's selecting the technology if we needed to do it at the machine. or more commonly, the program's already created offline, and then we just load it in, program's ready, good to go. Then we'd have our part, we'd pick it up and hit the start button. So,
Taylor, thanks for taking us through the process, selecting the technology, setting up program and all of that.
yeah, no problem. So, I've actually brought out an example of those parts that we were talking about. So here we've got the block where we've processed, those couple different orientations. And now what we're able to get is multiple parts out of one block. So one of these would actually be one individual part, but we were processing it all on one pallet. So now you can imagine if we put multiple pallets in the machine, now you can set the machine up and get all of this work done unattended. So that's kind of the idea with something like this.
Thank you. And thanks to our audience here. Thank you for joining us today.